Welcome protein coders, let's build some coding muscles. Today we're gonna see Dijkstra'S algorithm. So we have our guy Dijkstra and he wants to find the shortest path of each node from the starting node, okay? So here we have our guy DJ at node 0 and we have our distance vector, right? Now what DJ does is he uses a little bit of common sense, which you will see in a bit. So first he just saw the distance from 0, the nearest node's distance, which is node 0 to 1 and 0 to 2 respectively, which are 6 and 1. Right? Now what he thought was, let's see it in a graph here. So we have a node from 0 to 1 and 0 to 2. Now he first took the case of going 0 to node 1. So one way is we can go directly and it will cost us 6 units, okay? And the other ways will go from 0 to 2 and then we will take some other path from 2, okay? So what we can write is, we can write the distance of first 0 to 2, right, plus some, let's say, x distance, okay? And similarly for distance 0 to 2 we have two paths, right? One is directly go from 0 to 2, which will cost us 1 unit, right? And other path is go from 0 to 1 and then from 1 to 2, right? Let's write it as 6, which is 0 to 1 plus some distance y. Now here our DJ guy use his common sense. And what is this? Let's see. From going 0 to 1 we have two distances, 6 and 1 plus x. And from going from 0 to 2 we have two choices, 1 and 6 plus y. And as we all know, 1 will be always smaller than 6 plus y, right? Because the 6 plus y will always be greater than or equals to 6, right? So 1 will always be smaller than 6 plus y. But in the case of going from node 0 to 1, we have 6 and 1 plus x. X can be 1 also, x can be 2 also, x can be 10 also. So there we don't know, right? So we need to explore there, okay? So what's the conclusion from here? That from going from node 0 to 2, when we explored the neighboring nodes of 0, which are 1 and 2, right? We found out that to go from node 0 to 1, we have to explore. But in case of going 0 to 2, we found the shortest distance possible, which is 1, okay? So now what will be our next step? We will move to node number 2 and then we will explore again, okay? Let's mark our node number 2 with distance 1 and let me write it down here also. What we are doing is, when we are at node 0, we explored its neighbors and selected the nearest neighboring node for further exploration, okay? First let's mark 0 and node number 2 in our distance vector. Now let's explore from node number 2. So from 2 we will go to 1, 3 and 4 because 0 is already explored, okay? So now if you see, if we move from 2 to node number 1, earlier we has the minimum distance as 6, but now we have shortest distance to reach 2, which is 1 plus the edge weight to reach from 2 to 1. So 1 plus 2 is 3. So we'll mark it as 3. Similarly, 2 to 3 will be 9 and 2 to 4 will be 1 plus 1, 2. So now with the same logic of common sense which we studied, we will choose node number 4, node with the shortest reaching distance. So we have reached the node number 4 with the shortest distance possible. So we'll mark it, and in the next round we will explore from node number 4. Let's explore from 4. We will move to 3, and this time when we go from 4 we will get a new distance which is 2 plus 3. So earlier we have 9, okay? So we will take the minimum of it. Now again we will choose node with the minimum distance, which is node number 1, right? And from 1 we will explore node number 3. And as shortest distance to reach 1 is 3, so 1 to 3 will be 3 plus 1, which is 4. Again we got the new minimum. So we will update this in our distance vector. And that's how we get the shortest distances to reach all of the nodes from node number 0. Now let's see this in a more algorithmic way, how we're gonna do it. The logic will be the same only. So we have our graph and our explore vector and distance vector initialized with all infinities, and explore it's all zeros. So first, we will mark distance of source node with 0 and we will explore this node. Okay, from 0 we will explore to node number 1 and node number 2. Okay, and we will update their distances. So when we move to node number 2, we will update its distance to 1, and when we move to node number 1, we will update its distance to 7. Okay, now again in distance vector we will choose the other node which is at minimum distance and is not explored, which is our node number 2. So now we will move to node number 2 and explore the other unexplored nodes. First we will move to node number 1. This will be a distance 1 plus 2, okay, which is 3. Now we found a new shorter distance. Then 2 to 3 it will be 1 plus edge weight 4. This will be 5. Now from 2 to 4 it will be 1 plus edge weight 1, which is equals to 2. Okay, now let's update them into a distance vector. So we got a new minimum distance for node number 1, which is 3. For node number 3 it will be 5. For node number 4 it will be 2. And node number 0 and 2 are already explored. Now we will again see the minimum distance node which is unexplored, which is node number 4. So we'll explore from node number 4 and we will go to node number 3, which will be a distance 2 plus 3, which is again 5. So it will remain same. Okay, now we have two unexplored nodes which are node number 1 and 3, and 1 is the shortest one. So we will move to node number 3, mark it as explored in our explore vector and explore from node number 1. We will move to node number 3, which will be a distance 3 plus the edge weight 5, which will be 8, okay, which is greater than the earlier minimum distance. So it will remain same and 5. So we explored all the nodes. Therefore we got the minimum distances of each node from the starting node. So in total we are doing only 3 steps for each node. Okay, what are these 3 steps? First we are finding the node which is at the shortest distance from the source node. Okay, and we are marking it explored, and from this node we will again explore the other unexplored nodes. And finally, while exploring we are relaxing edges. That means updating our distance vector. Okay, whenever we find a shorter distance path, we will update our distance vector. Now let's see how we do it in our code. Let's have our explored vector initialize with 0 and distance vector initialize with int max or infinity, and we'll mark source node distance equals to 0. Now let's run a while loop for the number of nodes, because in every iteration we are picking up a node and exploring it. Okay, every iteration we will get an explored node. Now let's find the node with the shortest distance. So let's take initial node as -1 and let's iterate over the nodes. Okay, I equals to 0, I less than number of nodes, I plus plus. For every node we will check if it is not explored, and node is equals to -1. This is for the edge case, for starting case only, or distance of the current node less than the distance of the node from where we are exploring. So we'll just mark this as our new node, the new node from where we will explore now. Now we will mark this node as explored. Okay, now we will check for its neighbors. In adjacency list, let's get the neighboring node and also the edge weight of this neighbor node from the parent node. Okay, now if this neighboring node is not explored and distance of neighboring node is less than the distance of node plus the edge weight, we will update it. Okay, the simple edge relaxing. At the end we will return distance vector. See it carefully. What we're doing is, if the neighboring node is not explored and its distance is less than the parent node distance plus the edge weight, then we will updating it. Now let's revise what we have studied today. say Dijkstra, and we got a very common observation that for every step what we are doing is we are selecting the minimum distance node. We will go there and do exploration from that node, and we repeat this process. So what we observed is that we are finding the node at shortest distance, marking it explored, and from this node we will explore, and while exploring we are relaxing the edges, right? Then we saw the code for it. We took our explode vector and distance vector, mark the distance of source node as 0, and we run a while loop for the number of nodes. Then first we will calculate the node with the minimum distance, right? Shortest distance node, and we will mark it as explode. Then we will traverse its neighbors. If they are not explored and the distance to reach there, right, is less than the distance of, oh sorry, it should be greater than here. If the distance of neighboring node is greater than the distance of node plus the edge weight, right, we will update this. And for using priority queue and sets, we will see in the next video. If you have any questions, please ask them in the comment box. You will find the problem link and the solution link into the description box. Okay, if you don't understand, don't like, don't subscribe, but if you do, please show some support. Keep coding, keep smiling. Thank you.